Hi everyone, welcome to this video lesson on Cpctc. What we're doing today is more proofs proving triangles are congruent. And we're doing this with an extra step with corresponding parts of congruent triangles that are congruent. So what this means is if we could prove two triangles are congruent to each other, and we do that by side, 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 or by side, angle, side, or by angle, side, angle, or by angle, angle, side, or by hypotenuse, leg. If we can prove that two triangles are congruent, then their corresponding or matching parts are also congruent. So if we could somehow prove that triangle QRS is congruent to triangle TUV by, we'll say, angle, side, angle, angle, side, angle. Well, now by Cpctc, if the triangles are congruent, then their corresponding parts are also congruent. So now we can make the extra step and say, well, if the two triangles are congruent, then S has to be congruent to V. If these two triangles are congruent, then QS has to be congruent to TV. And if RS is congruent, or if the two triangles are congruent, then RS is congruent to UV. So that's what Cpctc says, is that if two triangles are congruent, then their corresponding parts are also congruent. Okay? So looking at this one, which triangle congruence theorem or postulate proves the triangles are congruent? Well, it looks like in triangle LMN, I have an angle and a side and an angle. And are those congruent to angle, side, angle? Yes. These two triangles are congruent, and the congruence theorem is angle, side, angle. So now it says, since the triangles are congruent, we prove that by angle, side, angle. What are the other parts of the triangles that are congruent? Well, by Cpctc, I now know that the other corresponding parts are congruent. So N, its angle, is congruent to S. It's the only angle that isn't marked with an arc, so I'll put 3 arcs at N and 3 arcs at S. Segment MN is between the 2 arc and the 3 arc angles, or it's the included side between those two. So that side is congruent to, in triangle SQR, the side that's in between the 2 arcs and the 3 arcs. So that one is right there. RS, that segment, is congruent to segment MN. And then, of course, LN is the third side that isn't marked, and that's congruent to SQ. And notice the location, side LN is the included side between the angle with 1 arc and the angle with 3 arcs. Same thing is true of SQ. It's between the angle with 1 arc and the angle with 3 arcs. So, since the triangles are congruent, what are the other parts of the triangles that are congruent? MN, that segment, is congruent to SR, segment SR. And we also said that angle N is congruent to angle S. Angle N is congruent to angle S. And then our third one is segment LN, right here, is congruent to segment SQ. LN is congruent to segment SQ. So that's what Cpctc says. If two triangles are congruent, their corresponding parts are congruent. So knowing that, I have another proof here, and instead of proving that two triangles are congruent, notice that at the very end, I want to prove that HK, this segment, is congruent to segment LJ. So I don't know that right now. That's my end result. That's what I want to find out. Okay? Well, if I could somehow prove that the two triangles are congruent by Cpctc, I can now say that those two segments are congruent if they're corresponding parts. So let's see if I could prove that this red triangle is congruent to this blue triangle, shall we? Alright, let's mark up our triangle. H, or KH, is parallel to LJ. So here's KH, it's parallel to LJ. And HL, that segment bisects segment KJ at M. So if it bisects it, if HL is the bisector, that means that KJ is split into two congruent pieces. M would be the midpoint of KJ. So now we know that KM is congruent to MJ. And if we know that KH is parallel to LJ, I'm just going to do this here for a second, this would be a transversal. So a transversal makes a lot of different pairs of angles, one of them being alternate interior angles. So angle J is an alternate interior angle to angle K, and alternate interior angles with parallel lines are congruent. And then we have another very common vertical angle scenario where angle 3 is congruent to angle 4 because they are vertical. So now, class, we have enough information to conclude that the red triangle is congruent to the blue triangle because of angle, side, angle, and angle, side, angle. So ASA says that these two triangles are congruent. So let's start writing down our proof. We have our statements. We have our reasons. We always list the given information first. Segment KH is parallel to LJ. This is given to us. And then segment HL bisects KJ at M. And this is also given to us. Alright, what else did we say here now? We said that KM is congruent to MJ. We said that KM is congruent to MJ. We said that because M is the midpoint, or because HL bisects KG. So it's the definition of what a bisector is. A bisector cuts a segment into two congruent segments. So it is the definition of a bisector. We also mentioned that angle K right here is congruent to angle J. Why did we say that angle K is congruent to angle J? We said angle K was congruent to angle J because with parallel lines, alternate interior angles are congruent. So for statement number 4, when lines are parallel, alternate interior angles are congruent. That's the reason why we could say that those two angles are congruent to each other. And then step 5, our last part of the proof for the triangles, is we said angle 3 and angle 4 are congruent because they're vertical. Angle 3 is congruent to angle 4 because they are vertical angles. Alright, so we have successfully proven that the two triangles are congruent to each other. So step number 6, we could list the two congruent triangles. So triangle KHM, that's the red triangle, triangle KHM is congruent. Now it's very important in the order that you write this now. Angle KHM, my congruent statement, angle K has to be congruent to angle J. So I have to say triangle J, and then after K I went to H, and H is congruent to L down here. So JLM, triangle JLM. And for our step number 5, the reason why we can say that these two triangles are congruent is because we did angle, side, angle. Angle, side, angle. Now this, in the past, has been when we've concluded our answer. But now, we don't want to prove the two triangles are congruent. We want to prove that KH is congruent to LJ. Well, if the two triangles are congruent, by Cpctc, congruent parts of congruent triangles are corresponding parts of congruent triangles are congruent, we can now say that KH is congruent to LJ. So that's going to be my last step. KH is congruent to LJ. KH is congruent to LJ, and step number 6, why can we prove that? Because of corresponding parts of congruent triangles are congruent. Cpctc. Let me know if you have any questions about that proof when you get to class tomorrow.